All right, students. Okay, so this is business mathematics. So we're already in week 5. Okay, so for this topic, will be talking about compound interest and its computation. Okay, and compound amount. All right. Okay, so the learning outcomes at the end of this lesson, you should be able to solve the compound interest, then recall the rule of PEMDAS, then analyze the formula methodology. Okay, why it's needed to recall the rule of PEMDAS? It's because the formula in solving the compound interest needs, you know, the rule of PEMDAS. Okay, so it's because it includes parentheses, exponent, okay, multiplication, division, addition, and subtraction. All right. Now, solving compound interest. Okay, so how to calculate compound interest? So compound interest or interest on interest. So it's calculated using the compound interest formula. All right. So the formula for compound interest is A is equals to P times 1 plus R over N raised to the power of N times T, where P is the principal balance, R is the interest rate, then N is the number of times interest. Uh, is compound per time period, and T is the number of time periods. All right, so solving compound interest, this is the formula. This is how it looks like. Okay. Okay, so the compound interest formula, so A stands for the amount, P stands for the principal, R stands for the interest rate. Okay, so in this part you have to convert the interest or the percentage into decimal. All right. So yeah, over n. Okay, times or raised to the power of nt, which is the p here is the time. N is the number of time. Interest is compounded per unit. Okay. All right. So the concept of compound interest is the interest is added back to the principal sum so that interest is gained on that already accumulated interest during the next compounding period. So how important is compound interest? Okay. So how to calculate compound interest rate formula? So to use the compound interest formula, you will need figures for you to have for your initial balance. No? Annual interest rate as a decimal form and the number of compound periods. So the number of times you want to compound the interest. So let's take a look at the calculation process. Okay, so this is the instruction how to solve or multiply or solve this interest compound interest, right? So multiply your initial balance by 1 plus the annual interest rate. Okay, it is in decimal form. Raise to the power of the number of compound periods. Then subtract the initial balance from the result if you want to see only the interest earned. Okay, so here is the formula. A is equals to P times 1 plus R raised to the power of T. This simplified formula assumes that interest is compounded once per period. So rather than multiple times per period or once per year, for example, right? So if you want to compound more than once per period or monthly compounding with yearly interest, for example, you'll need to use the advanced formula, which includes the number of compounds per period. So let's say this is the formula. A is equals to P times 1 plus R over N raised to the power of NT. All right? So actually, this compound interest is actually applicable, especially in insurance companies. Of course, now the how many or how much is the interest per month? How much is the interest per annum? Okay, so you have to familiarize the conversion of, let's say, for example, annually, monthly, or how many days. All right, so you have to familiarize this one. It's since this is important, it's especially in application of compound interest. All right, but the formula is the same. Based, yeah, the formula is the same, but depending on the agreement between both sides. All right. So if your company is or let's say for example you want to have an installment, no, or vehicle installment. So how much is the agreement? Let's say for example the interest rate per month is 2%. Okay. So you have to put the 2% there as R, or interest rate, and then get the principal value, okay, and the number of times, how what will be, or how long, no, the duration is. Okay, let's say for example 3 years. No, usually when we uh, have, or let's say for example we have an installment, or vehicle installment, or motorcycle. Usually here in the Philippines, it takes 3 years. No, usually the duration. So let's say for example you have the monthly of 3,000 or 5,000 pesos. Okay, so you have to calculate how much is the interest applied for that until the end of the what, the agreement. Okay, let's say for example 3 years. Okay, so you have to identify, or you have to calculate if the duration is, okay, or how much the interest applied in that duration. So your plan is about your plan is like you have to finish paying the motorcycle for 3 years, or let's say 2 years or 1 year. How much is the applied interest per month? Okay, usually it's per month, but there are like lending companies as well, or financing companies, that they will put or apply interest rate per day. Okay, so let's say 0.03% per day. So that's actually big if you can convert it into 1 month. So how much is 0.3 or 0.03% in 1 month? Okay, how many days in 1 month? 30 days. So you have to multiply. So it's the same thing. Okay. So here, where A, the future value of the investment or loan, including the interest. P is the principal investment amount, the initial deposit or loan amount. R is the annual interest rate. It is in decimal form. Then the number of times that interest is compounded per unit. The number, okay, so T here is the time the money is invested or borrowed for, right? Then this is the sign usually for exponent, okay, or the power of. All right. Okay, so don't forget when you multiply the exponent, so be careful because sometimes we are um, directly multiplying it, but that's not the rule. So if there's an exponent for that, then you have to multiply that number by itself based on the number of the exponent. Okay, so it's worth noting that this formula gives you the future value of an investment or loans, which is compound interest plus the principal. So should you wish to calculate the number interest only, so you need to deduct the principal from the result. So the formula looks like this. So earned interest only without the principal. So interest is equals to P times 1 plus R over N raised to the power of NT minus P. Okay? So this is earned interest, okay, without the principal. So that's why there is a minus P here to simplify that we remove the principal, or the principal amount. So let's say, for example, the principal amount is 10,000. So you have to multiply it based on the digits inside, or the variables inside. Then you have to subtract the principal amount based on the total of these numbers. Okay? So always remember that these variables are real number. Okay? So that's why you have to familiarize what are those numbers, or what are the function to it in a given problem. Okay? So, okay. So there's an example here. If an amount of $10,000 is deposited into a savings account at annual interest rate of 3%, compounded monthly, so the value of the investment after 10 years can be calculated as follows. Let's say, for example, what is the principal amount? So the principal amount here is $10,000. Okay, so the interest rate is 3. Why there is a hundred as the denominator? It's because this is how we're gonna convert the 3 into, or the 3% into decimal. Okay, so 3 divided by 100, that's 0.03, right? So that's in decimal form. So for n, okay, what is 12? It's because we got this 12 because of this annual what? Okay, this is for annual interest rate. Okay, So annual interest rate, so 1 year is equivalent to 12 months. Okay, that's why there is 12 here. Now, the time or the duration of the compounded or the plan or the loan is about 10 years. Okay, so that's why the T here is 10. Okay, so if we plug those figures into the formula, so we get the following. A is equals to $10,000 times 1 plus 0.03. This is the interest rate, the 3%, over 12, which is the annual. Then raise to the power of 12 times 10. 12 here is the number of months per year, and then you have to multiply it with 10. It's because this is the duration of the plan, okay, or the agreement. So the total, so when you solve this, okay, you can use the PEMDAS, or just if you have scientific calculator, then you can just directly solve this using it. Okay, so the answer is 13,493.54. So the investment balance after 10 years is $13,493.54, right? So for you not to be confused and at least you can recall the rule of PEMDAS, then I can give you the formula methodology, okay? So let's go through step by step how we get the 13,493.54 results. So our methodology revolves around the PEMDAS order of operations. So that is to say that we have to perform operations such as multiplication and addition in the right order. So P stands for parentheses, E stands for exponents, M stands for multiplication, D stands for the division, A stands for addition, S stands for subtraction. Okay, so this is the sequence when we solve equation. Okay, so we have to start with the parentheses. Second is exponent. Next is the multiplication or division, but this is can be interchanged. Then after that, addition and then subtraction. Okay, I hope you can recall this one because this is very important, especially if you don't have scientific calculator. So at least you can directly or you can just solve it manually. Okay. So let's start off with our equation again. So A is equal to 10,000 times 1 plus 0.03 over 12 raised to the power of 12 times 10. So using the order of operation, we work out the totals in the brackets first. So within the first set of brackets, you need to do the division first and then the addition. Okay, so division and multiplication should be carried out before addition and subtraction. So we can also work out the 12 times 10, which is, okay, like this. But remember that the parenthesis sign here is simplifies the multiplication. Okay, that's why 12 times 10. So this gives us 120. So A is equals to $10,000 times 1 plus 0.025 raised to the power of 120. So we solve first the parentheses. Now, okay, what is next? Okay, so 1 plus 0.25. So there's still parentheses, so you have to solve this first. Okay, so 10,000 is equals to 1.0025 raised to the power of 120. Okay, so this is supposedly 1.0025. Okay, so the exponent goes next. So we calculate 1.0025 times raised to the power of 120. So this we end up with 10,000 times. Okay, so this is the answer of 1.0025 raised to the power of 120. The answer is 1.3493555. Okay, so the round it off up until 6 digits or 9 digits. All right. So when we multiply the 10,000 times 1.3493555, the answer is 13,493.54. Right? So this is how we gonna answer this, or this is how we gonna solve this without using calculator. So with the rule of PEMDAS, we can just easily solve this manually. Okay? So I think this is the last one. All right. So thank you for your time. And if you have a question, you can just leave a message or comment your question in the comment section below. Thank you and have a nice day.